Good afternoon, everyone, and welcome to Layer by Layer, the show about 3D printing and our place inside the industry. Today we're going to talk a little bit about UltiMaker, a little bit about Formlabs, and we're going to finish up with a little bit about metal 3D printing. But before that, let's go ahead and pay the bills. This episode is brought to you by the Slant 3D, Etsy, and Shopify plugins. These plugins allow anyone to get access to our giant print farms, giving you hundreds of 3D printers for free. All you have to do is upload a file and then match it to a product listing on your Etsy or Shopify store. And then anytime somebody purchases that part, Slant 3D will print it and ship it directly to your customer for you. Now you have way more machinery, way more help, and you're able to focus on creating new products, creating an awesome marketing experience for your customers, and just enjoying life a little bit rather than all of the printing, packing, shipping, and maintenance that goes along with it. So go ahead and check out the Etsy and Shopify plugins and see if they can help you out as this Christmas season starts to loom to make sure that you don't shut down your store as Christmas starts to plow along. All right, so going into the news then. First piece of news, the new Form 4L 3D printers. And Formlabs opens up the material ecosystem. So yes, Formlabs just released a new, larger printer. We're not going to really talk about that. That is not news that we cover here on this show. However, with open materials mode, users can now introduce and use any material. The print settings editor gives them control over print settings, while the new API allows integration of third-party software with the printer. This is excellent news for scientists and researchers, as they can now easily use Formlabs equipment for research. Formlabs machines could become testbeds on motion stages for a wide range of research projects, and users can now customize the equipment to run on many more materials. While the company may forego some revenue, the move increases the likelihood that researchers, startups, and large materials companies will adopt the Formlabs ecosystem. More materials mean greater utility for the Formlabs machines, enhancing the value of its network. Okay. So yes, Formlabs allowed you to start adjusting settings. The first paragraph there tease it up as if it will be used for research projects. That's all fine and dandy, but any off-the-shelf resin machine allowed you to research materials if you were building that. And that is not why Formlabs is doing this. If I may editorialize a little bit, the value of a closed material machine ecosystem. There is value there, by the way. I know people don't like that in the 3D printing world, but there is real true value to having a cohesive system where your material works with your machine. It creates a much better customer experience because you know that material will work, and you also know from a customer support standpoint, if somebody comes to you and says, it's not working, you know where to look. Oh, the machine is broken, or you're in sunlight or something like that, whatever is causing problems with a resin 3D printer. But if the people are now able to adjust settings and introduce new materials, as far as I'm concerned, that's a voided warranty, basically. Operationally, that's not what Formlabs is doing. But when you let people modify the equipment, the responsibility for understanding what that modification could damage or cause is the issue. Now, the benefit to this for consumers is Formlabs resin is really expensive, so now you can buy cheaper resin someplace else. Where those two overlap or conjoin and go on or whatever else it was, really good customer service versus more customer competition or more competition around material sources, that's a decision any company has to make around what works for them. The open materials means that more people can use Formlabs machines because they don't have a negative buying decision around having to buy Formlabs material for forever. So that could increase the sales of Formlabs, but is that increase in sales commensurate with the increase of customer support that is now necessary from people putting the wrong stuff in the wrong place with the wrong settings? That's all the issue. So I don't know how Formlabs is addressing that. That is an operational challenge for them that they will have to deal with, but is what it is. Apparently this also applies to part of their SLS machines as well. But anyhow, cool. But to comment down below, what do you think? Is this a good thing or a bad thing? Are you going to be... It doesn't really matter if you're currently a Formlabs user because you can keep on buying Formlabs materials. But if you're someone who's wanting an open ecosystem, are you now going to purchase a Formlabs machine or continue using whatever DLP machine you were using before? Comment down below. All right, UltiMaker receives ISO 9000 and ISO 14000 certifications. BSI Group conducted a thorough audit of UltiMaker's operations and productions of its 3D printing solutions at its research and manufacturing facilities in Geldermalsen. I apologize to all the Dutch out there in the Netherlands. The independent audit noted that UltiMaker's management systems met the standard requirements for both quality assurance and environmental measures. The 9000 2015 certification affirms that UltiMaker is committed to maintaining high standards of quality management. Okay. This is news, but it's not news. An ISO 9000 certification is very common and comes up in any major factory will generally have ISO 9000, and many machine shops will have ISO 9000. If you're in the States, ISO costs about somewhere between $20,000 to $40,000 as a certification to obtain. I imagine that is similar in the Netherlands. However, this certification means one thing and nothing at the same time. 9000 means that you have a quality system. That's pretty much it. You have a quality system that meets the specs of ISO, which is basically you record what you do. That does not mean you are doing it well or right. For example, pretty much by the ISO standard, I could say, we're making cookie dough. Well, at the end of the cookie dough factory, we have a technician spit into every bowl of cookie dough as it goes by, and he records that he spit into it. That would be ISO certified because it is a consistent, recurring process that is documented. But was that a good process? No. The processes within any given organization are that's a little bit of an exaggeration because ISO wouldn't certify if you were contaminating stuff inside of it because that wouldn't hit basic safety reality checks. But in a more subtle way, we tighten down this screw in such a way or something like that that's silly or stupid, or we screw a screw into an untapped hole, something like that could subtly cause problems. ISO wouldn't catch that stuff. ISO does not make sure that your processes are good. It just makes sure that you have processes. So it doesn't really matter. We've struggled with this when we were messing with ISO here at Slant 3D. It's the fact that since our processes are so different, I was like, what does ISO do for us? Does it make sure that we are producing good parts? And the answer is no, it does not make sure that you produce good parts. It just makes sure that you are able to track when defects occur, when you are tracking those particular defects. But if new defects come up, all you could do is just say, the process is somebody saw the defect, but they threw it in the box, mailed it to the client, and then they emailed the boss and said there was a defect. That would be an ISO certified process, definitely. Not a good process, and we'd go out of business fast if that's what we did. But the point I'm trying to make is that ISO doesn't really matter and is a little bit of a poorly constructed certification, but is often used as a PR stunt to buffer up the quality of it. It just means that you're building a good factory that is recording what it's doing. 3D printed wallets. This was kind of a side story from Formlabs. 3D printing wallets. Lockcard is a fast-growing startup based on the south of Germany that aims to develop wallets with the smallest possible dimensions. Since releasing the key plate, previously known as the Lockcard, in 2020, they have developed a number of other modules, such as cache compartments and AirTag extensions, and they have sold over 100,000 products. At Lockcard, the Formlabs Fuse Series SLS 3D printers are an essential part of the business model. They are used as prototyping tools, but also to produce end-use parts sold to customers. This is why we told this story, in that SLS parts were actually getting made. We might do a real 3D printed products on this if we can actually get details on this. If people can give us more details about this product group of what parts are actually being printed and delivered to customers, we would love to do that. I don't care when printing is used for prototyping. That's very, 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 very old news. But anyhow, it is another product that is coming out of Formlabs and is being produced in real volumes. 100,000 isn't super high volume, but that's fine. The wallet world is dominated by Ridge. Well, the rigid wallet world is dominated by Ridge. But overall, just an interesting story. a human interest story of a product that is using printing. The team at Lockhart is constantly looking to optimize their daily operations, which they share the results of on their numerous social media pages. Many of these optimizations include the use of, that's PR. That's PRBS. Okay. Company updates. Now, let's see here. We are Tangled. If you did not know, Tangled is shut down until January. We will return in January. We will see what we're doing right there. But right now, our job is to focus all of our attention, quality, and personnel on making sure we are making good parts through things like the Etsy and the Shopify plugin. That is our only job. With Christmas starting up right now, or 3 weeks ago, we need to make sure that everything is teed up. So we are not going to be doing Tangled because Tangled is a kind of a fun to do project. It's not necessarily a good for the company project. And when we're doing with these really high criticality things, people who plug in the Etsy and the Shopify to us are relying on us to run their business. So they have to be reliable and we have to be reliable. And if we're playing with filament over there on the side, it's real tough for us to say, oh yeah, we're working hard on Shopify if we're diddling around with other stuff. So our job is to make sure that our machines are running quickly and well to make sure that all of our customers and clients are kept happy. So Tangled is shut down until January when we have bandwidth again and are outside of the peak period of the year. Etsy system, keep an eye on this. Very soon over the next couple of weeks, a little button is going to appear inside of it that will allow you to immediately and very seamlessly purchase a prototype of a part that you uploaded. So you can get into Etsy, upload everything, and then say, upload a file, match it to a listing, and then just say, purchase prototype, and a few days later, a prototype will show up inside the mail. This is to prevent people from having to go from Etsy, move over to the POD app, and mess around with that, because it's just cumbersome to be working over here, but then have to go over here to get like test prints and prototypes. We're just going to put the prototype app inside of the Etsy app. So that should be good. POD prints, yes. If you are getting POD prints, or if you're trying to get prototype prints, go over to Print on Demand. It's the quick prototyping app on the Slant 3D website, and you can just upload it, and then you get it. System updates in general. All API orders are now being pushed through version 17 machines. Our version 17 machines are new. They have new firmware, which is both for more high speed and the better surface quality in general. They've been deployed here for about this last year or so, but they've been kind of partner deployed with previous generation machines. We always use previous generation machines. But now all API orders will be going through version 17. Again, this is to make sure that those are turning out just as quickly as possible and that the quality is as good as possible. Previous generation machines, what we do is the factory kind of cycles out and there are grades of parts like whole functional, function forward, super performance, surface finish intended, that kind of stuff. To where older grade machines can be used for certain parts and pieces, kind of like an older processor can be used for slower processes. And then you want that bleeding edge one for your AI training thing that you want to get done in 2 seconds, that kind of stuff. That's effectively what we do within our print farms, is that the generations of machines are given particular tasks that they are rated for and are able to do a good job on. So if somebody is making an under dashboard bracket and they have fuzzy skin turned onto it, might as well loosen the belt to help that or something like that, and the part comes out better. That kind of a thing. As the machines, previous generations of machines age out, they're no longer able to produce new quality, new standards of parts. So the latest generation machines are making the latest parts on the API. So just so you all know, that's good and rolling. Okay. New section to the podcast. Tip of the week. Tip of the week is a conversation around how to do something that you guys are doing that we have some expertise on. So the tip of the week here this week is what are good, the tip of the week this week, let me rev this up. The tip of the week this week is around making what are good 3D printed products out there. When people are searching for new products in order to sell on their own or just as a category to search into what is doing well. The number one, accessories for tools. This is the big one. Accessories. Find a brand or a niche, DeWalt, Makita, whatever it was, Tesla, Nike, Crocs, something like that. Find something that has a fan base, has a group of people around it, and create add-on products to it. You can find, generally, this is best done when you are a fan of the product. If you are just searching it up and you go to whatever, the Makita forums or something, you won't know what the problems are. But if you are a Makita chop saw user, you know that these parts can be made by whatever, or that this is needed. And you have a value proposition, and then you have marketing. So accessories. Accessories are always a really good one because you have a pretty good understanding of the market. Secondarily, other good 3D printed products right now. Accessories are always great. But Chris, right now, holidays coming up, themed type products, again, kind of in tools. So something like a snowball maker or something for helping out with a Christmas tree. Those are good products at this time of year. Seasonal products generally aren't the greatest. You don't generally want to do that kind of stuff because it's not a sustainable business, but it's a thing that would sell fairly well right now. In addition to seasonality, if you have items that are configurable, like cookie cutters, night lights, that kind of thing, these should be reconfigured for the Christmas season. Coming down. And Thanksgiving. Halloween's kind of over. You're too late for it right at the moment, basically. But ultimately, those are kind of the base ones, the holiday season ones, and then accessories. Accessories are always ones that can be done. I'm going to tease this thing real fast. That's all you get to see from it because it's coming in a video. But that is a tool for woodworking that we are doing a design reacts and recreate video on. And it's a very good product because it caters to a set of people who need particular problems to be solved. So go solve a problem inside of a particular niche. That's the best way to go about creating a good product. Okay. The discussion of what is a good product, does it solve a problem? And by the way, entertainment products solve the problem of boredom. So that is how that works. Entertainment and fashion both always confused me in the problem-solving discussion. But entertainment solves the problem of boredom. Fashion solves a problem of status, is basically what it is. It is fulfilling a need, an itch for people to be liked, fit in, do that kind of stuff. So good products fulfill a need. And the clearest needs are problems, but there are more subtle needs such as entertainment and fashion and status. But manipulating and working within those is exceptionally difficult because they take a huge amount of nuance to do well. A problem is solved or not. It's binary. Whether something is fashionable or not. Best of luck to you, because I have no idea how it works. Okay, discussion topic. Okay, then. Metal 3D printing is stupid. Getting a rise from me in the notes. Metal 3D printing is not ready. It's still not finished. For all of the hype, all of the focus, all of the need for it, it's not finished. Metal 3D printing suffers from a very fundamental problem with physics, in that the vast majority, in that metal shrinks and expands. There has not yet been a metal let me back this up. There is a category of metal parts that could be produced. There always are. If you have a robot arm with a welder on the end of it, I'm sure that you could make some brackets for boats and trailers and semis and all kinds of stuff that would be very, very useful to those guys to replace casting and all the other things. But metal printing really suffers from the solution in search of a problem situation because all those people are using casting and traditional machining and that kind of stuff. And metal 3D printing really has a steep comparison curve when compared to machining, because metal 3D printing has not shown where it has grand advantages over those other processes, and in fact is objectively worse. as compared to like 3D printing. 3D printing has, polymer 3D printing. Polymer 3D printing has many clear advantages around distribution, supply chain, on demand, complex geometry, odd geometries. Some metals are able to do it, some are not. But when I referenced the physics problem earlier, metal either has a problem with scale or a problem with physics. The solution to scale has been binder jetting systems, or binder-based systems, where you print out a whole bunch of metal powder that's held together with some sort of goop, and then you center it, and you get that green part out, and then you center it. This is a fine way of cranking out a lot of parts because polymer binder jetting is a quite scalable process, reasonably scalable process. It's an expensive process. But while it can produce a lot of parts, you are now in a physics problem where those parts have to be cooked. And the dynamics of a green part burning away the goop that's holding it together and then centering it together creates shrinkage and warpage and a lot of different very dynamic problems that make it really tough to scale and take advantage of the core value of the 3D printing. 3D printing's fundamental technological differentiation from everything else is the fact that you should be able to make anything out of it at any time. Make a wheel, make a nut, make a thing, whatever it was. For metal 3D printing to be scalable with green parts, you have to basically build a process. You have to build the cooking recipe. You have to print off multiple prototypes, cook them all in different configurations and that kind of stuff packed with 10, packed with 50, packed with 1, and make sure they all cook appropriately. And then you never change anything and you just run the same part through that over and over again like a traditional factory. But there's no advantage from printing from that. That's just a big casting machine then, or molding machine that happens to use 3D printing. Now, if you have complex geometry, fine, but complex geometry hasn't caught up yet. So there's a problem on that side. The physics of learning how to cook a green part is not automated to where you can do high mix parts at scale. You can do scale or you can do high mix where you make 3 of them and cook them all and then one of them comes out okay. So binder metal systems have that problem. Non-binder-based systems, non-green part systems where you print with metal, where you have wire going in and a laser shooting it and then it melts one puddle at a time, that has legs. There is no reason that shouldn't work and shouldn't be very high precision and all the rest of it. The challenge with it now is it 10 times better than machining the part? Again, it's really expensive, not very scalable, because that process is slow and delicate. So you don't really have scale. Now, all of these curves will start to conjoin, but not today. So whenever I talk to people about metal printing, I just say it's early yet. It's still early. Metal has another 5 or 10 years before I hit what I would consider to be the same scale, similar to like what we do here at Slant 3D. I don't think metal's there today. Because you have this physics problem that isn't fully solved, and you have the scale problem for the direct energy systems, like a welder or a laser or whatever else it was. They all work fine. They make a good part that can hold up and all the rest of it. They're just don't knock many of those parts out. And it's tough to knock a bunch of those parts out because the process has to be so controlled. So that has a scale problem, and then binder systems that solve the scale problem have a mix problem because you can't take advantage of printing with those and create all the high mix. You can create complex geometries, but only if you're making a ton of them. So metal hasn't just streaked out in front of everybody else. That being said, the demand is there. Whenever I talk to manufacturers, they always say, can you 3D print with metal? And I don't know, and quite frankly, I always say, no, we don't do metal. We're never going to do metal. But So I never asked the follow-up question, why do you want metal? Because I don't care. It doesn't matter to me. But I should start asking that because I don't know why these traditional manufacturers are looking at it in that way. Because it's so, it does come up fairly regularly. But I think that's more kind of the hype of like some boss said we need to be looking at metal 3D printing because metal's in its hype cycle still. So I think that's the bigger issue rather than the actual need for it. But there are a lot of metal parts that need like spare parts and replacement, and printing can help with that, especially as machinists get rarer and rarer. So the labor shortage has a benefit riding up on all of this stuff. So no, metal 3D printing is not stupid. It's not a failure at all. All manufacturing processes will go towards additive at some point in the future. Additive is just the best process. It is the most efficient with the most flexibility. It will replace everything eventually. That's just the way that curve will, that's how the water's going to run downhill. Like printing is obviously the correct way of manufacturing stuff universally. But when does the technology mature to a level to where it's able to do that in an appreciable sort of way? Right now, I don't think metal's ready. I don't think anybody's shown how to get it done. Everybody has their thing, but none of it like just flies right out in front and loses it, which quite frankly is a universal problem because the 3D printing industry still focuses on the processes and the machines rather than what you can make with them. The industry needs to focus on what is a 3D printed product that these machines can make. And instead of designing machines and saying, go produce stuff, they should design product categories and then make a machine for that. Like when they started doing dental and stuff, that was addressing a problem in the market because they knew there was a market there. Everybody knew there was a market there. So it created this dynamic. But yeah, ultimately, metal's still early. The industry needs to focus on products rather than machines, and all of this stuff will get better. But there's only so many ideas for products that you can come up with. We deal with this all the time too. Quite frankly, like our API is a machine that we're saying, go figure out your amazing thing. The difference is that our machine is a huge enabler because you don't have to buy our machine. Our plugin, our Etsy, the API, all of them are basically free or so low cost that it's not really, it's the price of a cup of coffee kind of starter cost. So that is a different type of enabler. Because when we designed our products, which are these enablers that quite frankly are very similar to saying, here's a 3D printer, go make something cool with it. We have the same problem of like, what do people make? And the answer is that there's a lot of things out there that people are currently making with that model. So we designed our systems for the 3D printing entrepreneurs who want to scale up, product designers who want to use the products in some way if they've never been able to manufacture them before. And longer term, we have a strategy in place for helping with the creation of particular products that then feed straight through the system. So we're aware of the problem and we are dealing with it, but we got to go one step at a time because we're just a little startup. So we have finite numbers of resources. But there we go. All right, guys, that's it. Comment down below with other topics that you'd like us to go over and that kind of thing. Also, quick shout out to the other two YouTube channels. The Slant POD is over there. We've produced a whole bunch of videos on that reviewing Etsy stores and Shopify stores about how to make them make more sales because quite frankly, a lot of people just don't know. So we have kind of we're trying to, in doing these reviews, we realized, oh, here is a rubric for how to make sure your item is selling well. We're going to try to get that out in basically a PDF doc so that everybody knows. And over on those channels, we're going to talk about how to do free shipping and all that kind of stuff for your Etsy store so that you can maximize sales here during Christmas. So that's kind of what that channel is about. It's around the entrepreneur side of 3D printing, as opposed to this is the engineering and Tangled is the Uber engineering. So, but yeah, check out those other channels and let us know any other topics. Have a great day, everybody.